Okay, 2.4 complex numbers. No, that's just what we're doing. Okay, we are going to be using imaginary units. I'm going to try it. Using imaginary units to write complex numbers, adding, subtracting complex numbers, conjugates, finding complex solutions to equations. Recap of what we did last year in Algebra 2. There's nothing new in there. Okay, so an imaginary unit I, we've learned before, like this has no solution because you would subtract 1 and take the square root. And so I'd have x squared equals negative 1 square root, and I can't take the square root of negative 1, right? Mm-hmm. Oh, plus or minus. But I can, because the square root of negative 1 is I.
So x equals I?
The square root of, yes, in this case, x would equal plus or minus I. So we worked with them last year. We're going to keep working with them this year because last year you were introduced, you did some math, and they popped up here and there. But they will be pretty prevalent throughout the rest of your math career. So you have to know how to deal with them. Can't just like say, oh, can't do it. We wouldn't have electricity today if they did that because that's how they get it from here to there. We have an equation that has imaginary numbers in it. So, Alex, you good? Mm-hmm. Okay, powers of I. So, we start off with the square root of negative 1 equals I. We can leave it I. That's all good. Okay? Then I need I squared. Well, that's the square root of negative 1 squared, which is what?
1.
How about negative 1?
Yes.
Yeah? Okay, then I have I cubed. So that's I squared times I. So it's I times negative 1. So you get negative I. Then I have I to the 4th, which would be I squared times I squared, which would be negative 1 times negative 1, which would be 1. So any power of I can be broken down to I, negative 1, negative I, or 1. Because if I go I to the 5th, that's just I to the 4th times I, which would be 1 times I, which would just be I. So it's going to keep revolving. So the secret to it, because I to the 4th would be ideal, correct? That would like be the best to have. So I have x to the 2,376th. Okay? And I want the answer. And I don't think you want to write out 2,376 of them, do you? That'd be no. So if I divide this power by 4, because that's the one that's like the great one to have, right? So I'm going to take this number divided by 4. So I'm going to have x to the something to the 4th when I'm done, because 4 times would give me back to it, right? Okay, so 4 goes into 23 how many times?
6, no, 3.
5.
Jesus.
4 goes into 37 how many times?
9.
9. And 4 goes into 1 how many times? No, 16 how many times? 4. Well, oh, I read that wrong. This needs to be an I, not an X. Sorry. And I also need to have I to the fourth in the 5, 9, 4. Sorry, guys. Works either way, but this one's better. So what is I to the fourth? 1 to the 5, 9, 4, which is just what? 1. So this whole thing is 1. I was hoping it didn't go in there. I didn't do the math first. I should have. So what if it doesn't go in there? If it doesn't go in there, you write your I to the fourth to whatever number, like 238. And then your remainder, you put out on this other I. So if the remainder was 1, like 1, this whole thing would be what? 1 times I, which would be I. If you had I to the fourth to the 238, and you had 2 as a remainder, well, this is 1, and this is -1, so my answer is, see how that's working? You divide by 4, that's this number, and this is your remainder. So your remainder is going to be 1, 2, or 3, isn't it? That's it. So if I divide, and I have a remainder of 3. Well, this is 1, and what's I cubed? Negative I. So the answer is negative I. Whatever your remainder is your answer. Make sense? Do you want me to give you one?
Yeah.
Okay. We'll do it in a different color so it sticks out. So I to the 1,387th.
Okay.
Divide by what? 4. So you're going to have I to the fourth to the something, and then I to whatever the remainder is. Yeah, because I cubes. Okay, so these are the ones you need to know, because everything else falls into it. Did everyone get negative I? Olive? Okay. Okay, by combining real and imaginary numbers, we get a set of complex numbers. That's it. You don't need anything, no, but that, except for this right here is called a complex number. A is the real part, and BI is the imaginary part. Okay? In order to have a complex number, you have to have a real and an imaginary. I expect you always to simplify your answers. You should not leave them like what I have here. -5 plus the square root of -9. Well, before you had imaginary numbers, you'd say, oh, I can't do it because of the square root of the negative, right? So, but now we know all we do with the negative is make a what? I? Because this is the square root of -1 times the square root of 9. So I have -5 plus, what's the square root of 9? 3. So I have 3i. Now, these are not like terms. You may not combine them. When you think about math with them, you need to think like it's a variable. but it's not. It's a placeholder is what it is. It's a placeholder for the square root of -1. Or an even root of -1, to be honest. But, so again, it is not a variable, but we need to think of it like a variable. In terms of like combining like terms, all that stuff. Does that make sense? Okay, so a real number could be written as an imaginary number if your b was 0. So if I had 4, I could also write it as 4 plus 0i. Just the same as if you have any other number, you could put like 4 plus 0x, right? Because it's 0. Imaginary number is only if the b is not equal to 0. A pure imaginary number doesn't have a real part. Those are just some notations for you. Okay, equality of an imaginary number. This is one of those rules I think is duh. It's just one that we like. I have to tell you the rule, but it's one of those going, yeah, why would it be anything else? It says if A plus BI equals C plus DI, then A has to be equal to C and B has to be equal to D. Well, if I'm saying these two things are equal, wouldn't the real parts have to be equal and the imaginary parts have to be equal? Yes. So I have A plus BI equals 13 plus 4i. So what's A? 13. What's B? 4. No, just 4. Because there's an I there already. Okay, now, helpful hint. What do you notice about those I's and the I's that I've been writing? And the I's that you see in the typeset?
Those are like straight up.
They're straight up.
And
And
curvy ones.
yeah, you need to get some curve in there. Some people are dramatic. They go like that and do it. I think it's weird. I have a little bit on the top, but not. Just get a curve in there, just like your T's. Okay, so on the next one, it's going to be a little bit more challenging. Not really. A plus 6 plus 2bi equals 6 minus 5i. So what are the real parts on the left? A plus 6, yes? And on the right? 6. So A plus 6 has to equal 6. So A is what? 0, right? Okay. And then 2B equals 5. So B equals 5/2. It's one of those things that's like, it will trip you up, but it shouldn't, should it? Questions on that? Okay. I don't know if I'd write the rule. You add and subtract, like, you add real parts right here. When you add and subtract, this is what you need. Right here, that's it. To add and subtract complex numbers, you add and subtract the real parts, and you add and subtract the imaginary parts. That's it. You combine like terms. You don't mix them. I'm going to get tired of saying that.
Seems as if you already are.
Huh?
Seems like you already are.
It's just... Olive, let me know when you're good. When I first started, I did, like, here's the problem right here. I made everybody split up the real parts and split up the imaginary parts, and that just seems really excessive when I can say combine like terms.
Is this really all there is to it?
Well, I mean, you're going to multiply. You got conjugates in there. Conjugates are probably the hardest part of it. We did conjugates. So
I'm sure, but
I plus 6. The conjugate is I minus 6.
Oh.
So when I multiply it, it's I squared minus 36 because there's no middle term. And what's I squared? -1. So negative 36. So it gives me a real answer.
-37?
What is that?
Conjugates. The whole point of a conjugate is to get rid of something you don't want, and you don't want the imaginary number. So if you multiply by its conjugate, it gives you a real number. So,
See, I tend to not know words.
right.
I don't know what I'm doing if you tell me in words.
So I just got to keep using those words.
Show me equation, I'll do it. Not words.
Okay. Guys, these are just words you've heard before. Additive identity. What is the only number you can add or subtract to anything and not make a difference?
0.
Oh, 0, sorry. So what's the multiplicative identity?
1.
1. Those are the only numbers. So we have those. The additive inverse says the additive inverse, if I have a negative, I would distribute the negative. Correct. Okay, what's this? A plus BI plus negative A minus BI. What's your answer? A minus A is
0.
0. B minus B.
0.
So the answer is
0.
So that's why it's the additive inverse.
That's a lot for nothing.
Yes. Okay. Now, they will have parentheses around these, but on an addition problem, is it needed? No. So combine like terms. What do I get? Oh, stop that.
Sorry.
You're distracting me. Okay, what do I get on A? 5
Oh yeah. Oh yeah. Plus I.
plus I.
I know. How was your The next one, you get -3.
Because you have to distribute that, right?
Yeah, you get -3, 0.
So you get -3
So just -3.
and 0. But if it says, this is a tricky one. If it says write your answer as a complex number, don't you have to put the plus 0i? Yes. Now, I'm going to tell you right now in the online, it may not follow that rule. It should. If it says write your answer as a complex number, you have to put the plus 0i. Because -3 is a real number, correct? And a complex number has real and imaginary. So if they count it wrong and it's a 0i, then take it off and see what happens. But technically, if it says write your answer as a complex number, that 0i should be there. I don't write the program, so. Okay, does it get any more when I add more stuff to it?
No.
No. I have 3i, and then I distribute my negatives, so this would be negative, this would be positive, right? This would be negative, and this would be negative. So I have 0. So 0? Yeah?
No.
Yeah? I don't have any other real numbers.
No, 3i. -3i is 0 plus -5.
No, I'm talking about this, the real part's 0.
I thought you were talking about-
Real part always comes first.
No, I thought that we were done with the real part. We were
Oh,
done with the,
okay,
like,
no. The real part's 0. This is 0. So I have -5i. Again, if it says write your answer in a complex number, you have to put the 0. If it doesn't, I can just leave this, right? So just be aware. You'll have to let me know. I haven't gone. Actually, I can't do the assignment. Like, I can't go and do it. So next one, just distribute one negative, right? So I think I get 0 again for the real part, don't I? If I add it right. 3 plus 4 minus 7. 0. Then 2, minus I plus I, so it's just, that's weird that they both worked out that way.
0 plus 2i.
Yes.
You really got that shirt made.
I did not. A student got it for me. Thank you very much.
It's supposed to be factoring is fun, and then fractions are our friends.
Doesn't matter.
That student shouldn't have been in your class.
I say fractions are friends and factoring is
You
fun.
always say factoring is fun and fractions are our friends.
Okay.
You always say factoring first.
Yeah.
Okay, I'm sorry.
It should
Who
be
got
first.
it for you?
Natalie did.
Well, Natalie's.
We can let it slide then.
Okay.
No, we cannot.
So, just stop. Okay, so
Absolutely.
operations with complex numbers are the same as in the real number system. You have associative property of multiplication and addition. You have the commutative property of addition and multiplication. You have the distributive property over it. So like when you guys try to like distribute into here, I am like, no, you can't do that, right?
Huh?
Like into this quantity. You can't distribute the 6 in there, can you? No, because you have to do what first?
Exponent.
Exponent. But you can do everything with imaginary numbers just like if it was a variable. Okay? Just do your math like it's a variable. That's it. So what am I going to do with these two?
Multiply.
Multiply them. So I'm pretty sure I get 8 minus 28i.
21, isn't it?
No, that's 3 times 7.
Oh, I thought.
Plus 6i. You guys were making fun of me earlier. Now it's minus 21i squared. Okay? So the only power of I you can leave in a problem is 1. Only power of I you can leave in a problem is 1.
Is that 2i squared?
Yep. Because you have I times I.
When you-
I times I.
Yeah, it would be like negative 21.
Oh, I forgot the 1. I said 1 and I forgot to write it. Sorry. 21 I squared. Okay, so I have 8. And then what do I have here? Like terms, so I have negative 22i. What is I squared?
1.
Negative 1? Yes? So I have negative 21 times negative 1, which gives me what? Positive 21. So I scratch that out, make that a positive. So 21 plus 8 is
29.
29. What is the highest power of I that you can leave in an answer? 1. You can have negative I or positive I, but you can't have I to the 4th. You can't have I squared. You can't have I to the 28th. Okay? You have to reduce them. Questions? Okay, conjugates. AKA difference of squares. X minus 4, x plus 4. Correct? Those are conjugates of each other. Conjugates, those are all real numbers right here. X minus 4, x plus 4. When I multiply this out, what happens to the middle terms every single time? They zero out, correct? So, what we want to do, we have a complex conjugate, which is the same as a conjugate, but we're dealing with what kind of numbers? Complex. So it's really funny is after I teach this lesson, everybody wants to say complex conjugate every time they want to use a conjugate. So if you want to use one word every single time, let's just use conjugate. Okay? Because these are not complex conjugates. There is no imaginary number in them. Make sense? Okay, so if I have A plus BI, what's the conjugate? A minus BI. So that was the example that I just gave on the other side, and I'll do another one. So if I have 2 plus 3i, what's the conjugate? 2 minus 3i. The only sign that changes is the 1 in the middle, correct? So when I multiply that out, I get 4 minus 6i plus 6i minus 9i squared. Every time this is going to happen. So the middle terms, what? They zero out. What does I squared equal? So I have a negative 9 times negative 1, which gives me positive 9. So my answer is 13. Okay?
That's easy enough.
Yeah. And conjugates are used. You have to do it. You're like, oh, I need to multiply by the conjugate right there. When you want to get rid of what thing?
I.
The I. And whatever I do to the denominator, I have to do to the,
Top.
what's
Numerator.
the numerator? Thank you. See, we're learning words. Okay, what is the conjugate of I hate i's and ones. 1 plus I. 1 minus I. So my answer would be 1 minus I squared.
So 0?
No,
No, 2.
because I squared is negative 1. So it would be 2. Right? Okay, what's the conjugate of 4 minus
4
3i?
plus 3i.
4 plus 3i. So 16 minus 9i squared. So that's going to make this a plus, and it's going to be,
5.
okay? Now, what is the conjugate, I don't like that square root, of the square root of negative 15? There's a plus out here, yes? So it would be minus.
Yeah.
So that would be minus negative 15. So it would be
15.
15. One is a plus, one is a minus. What's the conjugate of 1 plus the square root of 8? 1 minus the square root of 8. So that'd be 1 minus, well, the square root of 8 squared is,
64.
no, it'd be the square root of 64, which would be 8. So my answer is negative 7. So we did conjugates with more than imaginary numbers. Can we do conjugates with more than imaginary numbers? Yes. I will tell you this one right here, I would probably not do the negative. If I had negative the square root of 15, I would probably just multiply it by negative the square root of 15. And the only thing that would change about my answer is it would be what? Negative. And we usually, no, this is called rationalizing because we would have 1 over the square root of 15, and we'll do this. Do we want a square root in the denominator? No, so we'd have to do this. And we typically don't want a negative in the denominator either, do we? So by doing the conjugate, it would bring it up. It would bring it, instead of having this, I forgot that, you would have this. And so you would have the square root in the numerator. Okay, so technically when it's just one term, the plus or minus isn't a huge deal in the front. But if you want to keep your mind on conjugates, that's what it is. And I will tell you in the textbook, it's going to want the negative in front of it. Okay? Complex conjugates, the reason we use them is to get rid of the what? Imaginary number. So we don't want a square root in the denominator. Guess what we also don't want in the denominator? Don't want a square root, which is an irrational number. We also don't want an imaginary number. Okay. So if I do not want an imaginary number in that denominator, then I probably should multiply by its what? No. Conjugate. Because what is the thing that we have to get rid of an imaginary number? Conjugate. So I have 3i over 1 minus I. So the conjugate of 1 minus I is 1. So I multiply down here and up there, correct? So in the numerator, just leave it 3i, 1 plus I for now. We won't do that. You want to do the numerator or denominator first?
Denominator.
Okay, because we know that is going to be 1 minus I squared. And what is I squared? Negative 1. My screen keeps jumping on here. Okay, so this is negative 1. So negative 1 is 1, so you get 2. So then here, just distribute, correct? So I have 3i plus 3i squared. Well, what's I squared? Negative 1, so this isn't a positive 3 anymore, it's a negative. Now, I said that it is a real part plus or minus the imaginary part, correct? Right now we have the imaginary part first. What needs to go first? The real. So it's going to be negative 3 plus 3i. Now, do I have real and imaginary separate?
What?
What are they joined by?
2?
The 2. And I need them separate. If I can add fractions because they have common denominators, can I also tear them apart? Yeah. So you need to write them separate. So you have the real part plus the imaginary, but the number goes here and the I goes off to the side, not in the numerator. You need to be able to look at this number and say the real part, the imaginary, coefficient, imaginary. Got it? I will have people go, well, I separated it, and they will do this. Is it separate? No. I need to see those 3 separate parts. And if you could reduce the fractions, you would. Like if one of them was 6 over 2, you'd reduce it to just 3. This is probably the hardest part. Because you just have to remember to use the conjugate. Okay, I am going to stop here for today. Well, good thing. I know there's a few more notes, but this will get you a huge chunk of your assignment. It'll be over half of it.